Hi, today we're going to talk about some proofs and in reference to proving triangles congruent. So we're referring back to the lesson where you're looking at a triangle and you're trying to decide if it's congruent by SSS, SAS, ASA, AAS, or HL. So before we start, we need to take our given information and plug it into the diagram. So it's very important that you download these notes to Cami or you have it written out before we begin so you can use your diagram and follow along as we go. So first of all, in this first example here, I already have it completed for you. We know that AB here is congruent to CB, and I already have that marked. We know that BD bisects. Now, bisect means it cuts it into two equal parts. And so, as you can see, I marked these two little angles as equal. And if you look, they only gave you two pieces of information. We needed a third piece, and I went ahead and marked that. Whenever they share a side, BD, BD is congruent to itself because both triangles share segment BD. So BD is congruent to BD. The top triangle BD and the bottom triangle BD have the same measurement. Let's go back. Okay, so we need three things we're proving. So when you look at this diagram, let's zoom in. You have a side and you have a side, and this angle is directly in between those sides. So we have side, angle, side. Now we're just going to go through and list this information, how we knew it was side, angle, and then a side. Now I always start with the given information. So I'm going to take this first given, and if it's not already here, list it. And then I write given. Now, I know I'm finished with this step because I already showed the two segments are congruent. Now, my second piece of information doesn't show anything congruent. I need to go ahead and write it as my next step, and I write given, but I know I need to keep going because this step tells me information, but I need to apply it. I need to apply it so I know what two things are congruent. Does it tell me two sides are congruent or two angles are congruent? And as you guys know, if you're cutting a big angle in half, it tells you that the two angles are now congruent. You had to know a vocabulary term. We had to understand the word bisects. So for this step, I said definition of bisector. Good. Now, as you do this proof, you're going to have to show three things are congruent. So like here, this was your side. Now you don't have to label it this way. If you want to label over on the side, you could say, okay, I prove the side. Here on the next, where'd my, oh my, it keeps getting worse. Okay, on the step 3, I proved my angle, and now I need to prove my side. Now remember, BD is congruent to BD. We just talked about it. It's congruent to itself. This is the reflexive property. So after you prove the side, the angle, and then the side, then you're just going to say, ta-da, I prove the triangle's congruent. So you write the congruency statement. Now, if it's not already written for you, you have to make sure it's in corresponding order. But if you look up next to your givens where it says prove, it tells you what you're proving. So remember, you can just look up here and bring that down as your last step. And we knew we proved it by side, angle, side. And we knew that before we began. So don't overthink this. You guys got this. We're looking at this and we're just explaining how we knew it was side, angle, side. Okay, so there are some hints over here on the left. Hint 1, you have to use one of the 5 methods. We understand that. Each line between the given and the bottom help prove one of the three congruent parts. Okay, so again, your givens help you lead to a conclusion, and you're trying to prove the three things, either side, 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 the side angle side, and so on. And your reference sheet from last chapter, you can use it if you have it. If not, we can get you another sheet, or you could use your notes from last chapter. Okay, let's try number 2. Again, where you start is looking at the diagram, which currently has no information. So we're going to look at the givens and plug it in. JL is congruent to NM. Okay, K is the midpoint of JN. So find JN. So if K is in the middle, that means the left side is congruent to the right side. And wherever I lay my hand, my computer is not happy today. Now, it also says K is the midpoint of LN. So here's LN, here's the midpoint. So that means the left side and the right side are equal to each other. So now when you kind of step back and look at it, do you have enough information? And you do. We have enough to prove side, side, side. And I always write it down so I don't forget. We're going to prove this by side, side, side. So again, we're going to use all this given information. Your last step here, as you know, goes in the last blank. Before you even begin, if you want to go through and write given, every place you see given, that's a good technique. So step 1 is given. Step 2 is given. Okay, now this one is congruent, and that was a side, so we already proved one side. Step 2 doesn't show anything as congruent, so we didn't prove anything yet. So that means we have to apply that. So if K is in the middle, what did it form? So again, we're referencing, let's do JN. When you have segment JN and it cuts it into 2 equal parts, it makes the left one, which is JK, and it makes the right segment KL or NL. So what definition did we use? Well, the only definition in the prior step is midpoint. So this is definition of midpoint. Now, your given actually told you in step 2 two things. It says K is also the midpoint of LM. So let's look at LM. When you have LM, remember it cut it into 2 equal parts, the left side and the right side. So the left side is called LK, which is correct, and the right side is MK, which is correct. And so again, what definition did we have to understand and apply? This is definition of midpoint. Now, if you look carefully, we have, oh my goodness, we have enough information to prove this. We have 3 things congruent. We have a side, and a side. And now we have our congruency statement. And so now you're going to tell me, what shortcut did we use? So every time there's a congruency statement, you're going to use one of the 5 ways: SSS, SAS, ASA, and so on. So we're going to say side, side, side. Good. All right, let's look at the thoughts and hints for this section. It says use the given to put the tick and congruent marks in the picture, which we're doing. Which congruency criterion are we going to use? Does the given provide any of the 3 congruency criteria? And what information do we need? All right, so this is everything that we just keep talking about. So let's try this next one. Let's take the given and insert it into the diagram, JM, is congruent to LN. Now, this might get tricky. Let's connect the dots. JMN. So that big angle right there is congruent to LNM. And that's all they give you. We need 3 things. They give us 2. Now, if they share a side, let's mark that. There shares a side. So I'm going to put 2 little tick marks there. All right, so we need to look at this and decide how we're going to prove it. So I have 2 sides and an angle, and the angle is directly in between. So you have the 2 sides and the angle that's directly in between. So this is side, angle, side. So let's go through and put all the given information in. The first 2 steps are given. So half the proof is just writing given. Now, I typically don't write it this way. When I write it, I always just write it exactly the same. I say MN congruent to MN. Guys, it's the exact same thing. When you write a segment, you can change the order of the letters. So don't be confused that it flipped it and said NM. It means the same thing. So whenever they share a side, that is reflexive property. Hopefully you remember that from last chapter. Whenever you have a congruency statement, this is where you're saying, yes, they are congruent, and this is the reason why. We found that before we began. It's right there at the top, SAS. Perfect. Guys, you just got to give these a shot. They're really not so bad. Now, this one was done for you. It's a little bit more difficult. I'm going to talk you through it. This little symbol that you see here and here, that means parallel. Now, this is a hint. This is a major hint that you have angles. When I say angles, I mean like corresponding angles, alternate interior, alternate exterior, same side interior. So you have to know the lines are parallel, and then they're going to tell you a certain kind of angle. Okay, so let's just start. JK right here is parallel to LM. Perfect. And this little symbol that's written right here, that little purple arrow thing, which I'm going to make it a black one, that means they're parallel. That's the way you would draw into your diagram. So let's keep reading. Now it says it's also parallel the other direction. So notice now there are 2 little marks. It's different than a congruent mark. That just tells you it's congruent, or not congruent, it's parallel the other direction. Okay. Now that's all they give you. Okay, that's it. Now let's slow it down. Let's go back to this one. If you have these lines that are parallel, and this is your line that is transversal, technically these 2 lines could be parallel or could be congruent because they're alternate interior angles. Do you guys remember alternate interior angles? Remember anything in between the 2 lines are interiors, and they are alternating on each side of the transversal. So why are these 2 congruent? Alternate interior. Now, what happens if I draw the lines going this way? Keep the same transversal. You see that I have angles formed here. And those are also alternate interior angles because everything in between here is interior and they are alternating. So they're alternate interior angles. All right, so let's look back at this proof. How did I know in step 2 these 2 were equal to each other? Well, we just talked about it. They're alternate interior angles. Don't worry about saying theorem. I'm just worried that you know what kind of angles they are. Okay, how did we know here in step 3 those 2 angles were congruent? Again, they were alternate interior angles. And it's just abbreviated here. You can write it out, or abbreviate either way. And this middle segment, we've had this several times already today. We know that means it's reflexive. And again, for step 4, if I were writing the proof, I always write them exactly the same. For my class, I always call it copy and paste. They're exactly the same on the left and right side, but they're the same segment regardless. Now, how did we prove this? I don't know if we've actually talked about that in this one. We got so concerned about all the parallel lines. We have an angle, we have a side, and we have an angle. So it's angle, side, angle. Sorry, that's my bad for not going over that first. Angle, side, angle. All right, thanks for sticking with me. Now, we're going to change it up. Now, if you notice, what we're proving is not a congruency statement. We're going to go one step past that. All right, so hang on. Let's plug in all of our givens. AB is congruent to AD. BC is congruent to CD. And the side they share is the R word, reflexive. Okay, so you have 3 givens. 2 givens, I apologize. First given, that's a side. Second given, that's a side. There's nothing else you have to do to those. They already showed that they're congruent. The side that they share, AC, and this is written the way I like it. AC is congruent to AC. This is your third side. It is reflexive. Now, after you show all 3 sides, this is where you write your congruency statement. So remember, the first triangle, you can write any order you like. And so I chose BCA. Then you have to go slow and say what corresponds with B. And so correspond again means they match locations. If you were to fold the triangles on each other, what would match with it? And that would be D. C corresponds with C, and A with A. All right, good. Now, we have to take this one step further. Now, when you look at this picture, it talks about only sides. There are actually 3 sets of angles that we've not yet talked about. But since the triangles are congruent, technically, those angles would all be congruent. So let's take a look at this picture. Technically, if the triangles are congruent, isn't A over here in this A, I know that's confusing, aren't they technically congruent? And isn't B technically congruent to D? And then the 2 little angles, I'm trying to put 3 little marks. Aren't they technically congruent? And they are. So we could talk about any of those. So it's kind of like one more step past the congruency statement. And so we could pick any of those 3 angles because technically they're all congruent. So on this proof, they chose BCA and DCA. Really, they could have picked any of the 3. It was whoever wrote the proof's choice. Now, this is an abbreviation, obviously. This means corresponding parts of congruent triangles are congruent. Now, let's slow this down. Are these 2 corresponding? Is this angle here corresponding to this angle? Yes. Let's write down these words. Corresponding parts of, now are the triangles congruent? Sure, we proved it in step 4. Of congruent triangles are congruent. All right, now no one wants to write that out. That takes a long time to write. So we just abbreviate it, CPCTC. CPCTC. So you have to kind of memorize it, and that's it. It's not more difficult, it's just understanding there's one more step past that congruency statement. It's always those 5 letters, CPCTC. So we get to try one on our own. All right, let's get rid of some of these. So we have space. All right, so it starts out with parallel. Parallel means it's a hint, right? It's a hint for angles. So let's draw it into the picture. These 2 are parallel. All right. So I'm going to go ahead and write that. BC is parallel to EF given. Now, I know I'm not finished with it because nothing's congruent yet. Now, really on this one, there are two transversals possibilities. So technically, that could be my transversal, or it could go the other way. So I'm going to see if it matters, because this is the first time I completed this proof. I'm going to say those two are alternate interiors. And if it's not right, we're just going to go back and fix it. It's trial and error. So what's the name of those two? Let's get rid of some of these lines. Angle C is congruent to angle E. What kind of angles were they? Do you remember? If this is parallel and this is parallel, and that's your, ooh, that's a bad transversal. And this is your transversal. They are alternate interior angles. All right. And again, if it doesn't work out, we'll fix it. Now I proved something congruent, so I'm going to move on to my next given. D is the midpoint of BE. All right, so let's find BE. Is that BE? Oh, it's BF. Sorry, I couldn't see it through my letter or my line. So here's BF. So that means the left side is congruent to the right side. Now, what's the names of those two segments that are now equal? What's the name of the left segment? What's the name of this segment here? It goes from B to D. And what's the name of the segment on the right? It goes from D to F. All right, so let's make this correct. Put a line on top of the congruent symbol. All right, so how did I know this? What definition in step 3 would tell us this? This is definition of midpoint. Now, again, I don't have enough information. I only know 2 things. I need to know 3 things. And let's review real quick. I have an angle. I have a side. I need something else. Now, let's review our choices. Side, 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 angle, side, angle, side, angle, 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 side, and HL. Now, we know ASS doesn't work, right? So we know we're not looking for a side unless it's side, angle, side. We know angle, side, side doesn't work. So we know, really, we know vertical. Is that going to be anything? So if I have this, I have an angle, I have an angle, and then I have my side. Let's check this one. Angle, I should put a slash there. Angle, angle, side. So yeah, it's going to work. Angle, angle, side. Great. Now, let's do our vertical angles. Now, if you do angle D is congruent to angle D, that causes confusion, and we can't do that. We need to use 3 letters. So let's do this top one. We just use the 3 letters. The vertex D has to be in the middle. BDC is congruent to, and then let's do this bottom one, EDF. Perfect. How did we know that? They're vertical angles. So we're going to use the vertical angle theorem. Vertical angle theorem. Perfect. Now, did we prove enough? Do we have an angle? Do we have a side? Do we have an angle? Yes, we do. So we're going to write a congruency statement. Now, here's the, ooh, why did I erase all that? Don't know. Here, hold on. B, D, C. Mrs. Provine's kind of forgot what she was doing for a second. B, D. Okay. Let's pick a triangle, top triangle or bottom triangle, and put it any order you like. So I'm going to pick the top triangle and just say B, C, D. And now the second triangle has to be in corresponding order. So just because B is on the left doesn't mean it's going to correspond with E that's on the left. Use your markings. B technically doesn't have a marking at all. So it's going to correspond with F. C has one little marking, so it's going to correspond with E. And D is vertical with D. And then you're going to say, how did we know they were congruent? And of course, that was AAS. Now we're going to finish this up with what we're trying to prove. We're going to bring it and drop it down in the last step. Segment ED is congruent to CD by those 5 letters, CPT, CP, CT, C. All right, so I know this is a lot. You're not going to be given a totally blank paper and asked to fill it out necessarily yet. So just relax. You'll get it. There's going to be little parts and pieces in here that will help you out. But every year, people do well on this lesson. All right, so we have one more to do, and we are finished with notes today. Let's look at JM, and it bisects KJL. All right, so that means we have this big angle, and this is cutting it down the middle. So we have this angle is congruent to this angle. So let's clean the picture up. These two angles are congruent. Perfect. Next, JMK, connect the dots, J to M to K. So this big angle here is congruent to J to M to L. So those angles are congruent. Now, what's our last piece of information? Because that's only 2. Hopefully you see this little side in the middle that is reflexive. I kind of didn't give myself room. But we have enough information now to prove it. This is an angle, a side in the middle, and an angle. So we're going to prove it with ASA. All right, so let's go through and list our given. JM bisects angle KJL, and this is given. Now, because it bisects it, what did we know? Now, a big hint is that vertex is J. So when it cuts it, J is going to remain your vertex. So let's talk about this top angle first. What is the name of it? Let's start with K. So it's KJM. So KJM is congruent to the bottom angle, which is here, which is MJL. Perfect. Now, how did we know that? We knew that because of this vocab word that's in step number 1. Definition of, you could say angle bisector or just bisector. All right, now we're finished with that step. This is an angle. And so we already proved that. Next, let's list this given. JMK is congruent to JML, which we already have in the diagram, and this is given. And again, this is another angle. It doesn't have to be in order as long as you have all the information. So it's okay that I didn't talk about the side next. So now let's talk about the side. The side is this side here in the middle that they share that we've had so many times already. Whenever they share the side, it is reflexive property. So now we have angle, side, angle. Again, I can't stress enough to you, it's okay. It's not in the right order. You have the information within your proof to prove the pieces and parts that you want. Next, congruency statement time. The first triangle could be in any order that you like. I'm going to choose that order myself, J, M, K. The second triangle is dependent on the first triangle. So I say J corresponds with J, M corresponds with M, and K corresponds with L. And I have to say it's by ASA. And then lastly, what we're trying to prove, JK is congruent to JL. And this is those 5 letters, CPCTC. All right, and that is it. So we're going to do another day on proofs, but I'm going to show you a different way to do proofs, but it's the same information. It's just a different layout. So come to class with lots of questions or join a help session, and best of luck.